This is Unit 2, Lesson 9, Solving Problems about Proportional Relationships. And this is Activity 1. What do you want to know? And so what do you want to know about this race in order to figure out at what time will the person running the race, will they finish that race? And so what information do you need to know to help solve that problem? So all of these problems that have to do with movement over a distance, they all have two properties. One is that distance, and the other one is how long it takes to cover that distance or move through that distance. And that information is connected by the ratio of the distance and the time. And that ratio is the speed. So the distance per time is known as the speed. So think miles per hour. So you all know about miles per hour. That is the speed that you're traveling. As you're riding in a car, you're traveling at 25 miles per hour. That's the speed. That's telling you what's the distance you're going to travel in 1 hour. So if you know the total distance and if you know the start time, then you can figure out how long it takes to run this race. And if you know the start time, then you just add that length of time onto the start time and you get at what time they finished. So if you have the distance is equal to the speed times the time, so this is y equals kx. So this is the ratio, the distance per time. So the distance is y and the time is x. So y divided by x is equal to speed. And then you can just write this as distance equals speed times time. And if you can, if you're given any two of these unknowns, then you can solve for the third. So if you're given the distance and the time, you can figure out the speed. If you're given the speed and the time, you can figure out the distance. And if you're given the speed and the distance, you can figure out the time. So you just need to be given two out of these three parts of the problem. So in this case, it says, if you have this information, how do you use that information to solve the problem? So they give you the distance, 10,000 meters, and they give you the time that they start. So they start running at 9:15 in the morning. And the other four of these items, they're all the same thing. They're all giving you the speed. So any of them will work to solve the problem. So A is telling you that they cover 156 1/4 meters per minute. So that's the speed of the runner. B is the same thing. So right here in the equation, distance is equal to speed times time. So it's 156 1/4 meters per minute. So B is the same. C is also the same. It's just given to you as 5,000 meters in 32 minutes. So if you simplify this down to how far is that per minute, you're going to get an answer of 156 1/4 meters per minute. And D is the same. It's just giving you twice the distance and twice the time. So it should be 10,000 meters, not 1,000 meters, but this should be 10,000 meters. Oh, I'm sorry. D is giving you 1,000 meters, so it's giving you 1/5 the distance and 1/5 the time, which works out, by the way, to be 10,000 meters in 64 minutes, which would then be twice the distance and twice the time. So if you simplify this, you're going to also get 156 1/4 meters per minute. And I think that C is probably the easiest one to use to solve the problem. If you're running 5,000 meters in 32 minutes, and that's going to take twice as long to run twice the distance. And the distance of the race is 10,000 meters. So it's going to take 64 minutes. So 1 hour and 4 minutes. So if you add that 1 hour and 4 minutes to 9:15, you're going to finish at 10:15 plus 4 minutes equals 10:19 in the morning. And here's using the equation. I just used the relationship right here to solve the problem. But these are problems designed to have you use the equation to solve them. So let's write the equation. It's distance is equal to the speed times the time. How do I know to write that? Well, the distance per time gives you the speed. That's the speed. And then you can rewrite that as the distance is equal to that speed times the amount of time. And so 10,000 is the distance of the race, equals 5,000 meters per 32 minutes. That's the constant proportionality. Now, it's not simplified, but it is a constant proportionality. It's a ratio between the distance and the time. And then what you don't know is the amount of time that it took. And so now you can rearrange this to calculate the amount of time by multiplying by the reciprocal of this constant proportionality. The reciprocal is 32 over 5,000 times this 10,000 meters. And you can rearrange this to write it as 10,000 over 5,000, 10,000 over 5,000 times 32. That's just switching the 10,000 with the 32, which you can do. It's using the commutative property of multiplication. So 10,000 divided by 5,000 is 2. And so you end up with 2 times 32, which is right here, by the way. This 2 times this 32 gives you that 64. That's how you got that answer. So 2 times 32 equals 64, so the time is 64 minutes.